Good morning, students. Welcome to chemistry class. I hope you all are doing well. I hope you all remember what you had learned in the previous classes. So, we were talking about matter around us. Is matter around us pure or not, right? We were also talking about homogeneous mixtures and heterogeneous mixtures. What are mixtures? When two or three components are put together, they are called as mixtures. What is homogeneous mixture? When the components in the mixture are distributed evenly in the component, right? And heterogeneous, it is distributed unevenly. So today, let us learn more about these matter which is around us, whether it's pure or not. Let's learn more about the mixtures, okay? So, what do we see here? We see a father who has come back from the market, okay? So, he has a basket in his hand. What is in the basket? Let's see. We also see his son waiting for the father. So, they are having a conversation, and let's see what the father is up to now. So, father keeps the basket which is taken from the market on the table, okay? So, what do we do usually when we come from the market? So, when in case we are buying vegetables, the first thing our parents will do is they put it upside down and then they separate these vegetables. No, the carrots are in one place, the onions are in one place, tomatoes are one place, and then they put it either in the fridge or they keep it separately, right? So that is what we do when we come back from the market. Let's see what father is up to here. So the son puts the basket upside down. So what do we see? We see a lot of vegetables here. All of them are mixed together. So what is happening here? It's a mixture of vegetables. There are a lot of vegetables in the basket and he's putting it down into the table. So what is he up to do? So what is he trying to do here? He's trying to segregate the vegetables. So one of the vegetables in the one side, the cucumber is on the top, the other vegetables are in the other side. He's trying to separate them, right? This is what we do in our households. As soon as we come back from the market, we separate all the vegetables, right? So, do you think we can separate milk also in the same way? Do you think we can get cream, yogurt and cheese from milk the same way? Can we just separate all the components from the milk and get all these things? Do you think that is possible? Let's find out, okay? So, in one side, we have this pile of vegetables, which is all mixed together, right? And then on the other side, we have this milk, cream, yogurt and cheese. So both of them are mixtures, right? Milk is a mixture of water and milk component. And here the vegetables, there are a lot of vegetables in it. They both are called mixtures. What are they called? They call mixtures. But what is the difference between these two? Are these both the same thing? Is milk and the pile of vegetables the same type of mixture? No, right? We've learned something about this before. So, the pile of vegetables is called heterogeneous mixture. What is happening? A lot of vegetables are mixed together unevenly, right? You can see some carrots in one side and then you can see some beans on the other side. So this is unevenly distributed. So you can easily separate it out. So this is called heterogeneous mixture. What about milk, cream and all? They are called as homogeneous mixture because the components are evenly distributed in these substances. You cannot easily separate them. So in the milk, in cream, in yogurt, it is all evenly distributed. So this is called homogeneous mixture. So what are the two types of mixtures? Heterogeneous mixture and homogeneous mixture. Okay. So how do we separate this? Vegetables, so you know, we can separate it by our hands, right? That's what we do every day. But do you think we can separate milk, cream and yogurt the same way? Can we use our hands to separate it? No, right? So how do we separate it? So that's what we're going to learn today. So to separate homogeneous mixtures and heterogeneous mixtures. Before that, let's have a question time, shall we? So, solution which has uniform composition throughout it is called as what? So you get 30 seconds of time. The option is A. Homogeneous solution, B. Heterogeneous solution, C. Colloidal solution and D. None of these. What do you think, students? Solution which has uniform composition throughout it is called what? Let's see. You have 10 seconds of time. Now 5, 4, 3, 2 and 1. Yes, you guessed it right. Solution which has uniform composition throughout is called as homogeneous solution, right? I hope you all have guessed it right. Let's move on next. So, separating the components of a mixture. Let's see how can we separate the mixture or the components which are present in the mixture. Again, let's see how to separate them, okay? So, different methods of separation are used to get individual components from a mixture. So, there are several types of methods. Maybe it's a homogeneous mixture or a heterogeneous mixture. There are different methods to separate them to get the individual components from these mixtures. Heterogeneous mixtures can be separated into their respective constituents or individual components by simple physical methods. So, simple physical methods like the pile of vegetables. So, that is a heterogeneous mixture. So, we use simple methods to separate them, no? So, in the same way, these heterogeneous mixtures can be separated into their individual components. Maybe carrots separate, the onions separate, the tomatoes separate, all these respective constituents by simple physical methods. Let's see what are these simple physical methods. Okay. So we have a scenario here. We see a lady, she's trying to separate something. So we can see a pile of pulses and cereals kept on in the front of her. And she is separating the impurities from that pile. Okay. So what is she doing? She is using her hand to separate this pile of cereals, to separate the impurities from this pile of cereals and pulses, right? So this is called hand picking, where you use your hand to pick all the impurities and separate it from your required components. So these impurities are separated into their individual components. So what is here happening? So she is using her hand. So this method is called hand picking, right? We also use hand picking to separate the vegetables, like we saw on the first slide. So this is called hand picking method. This is a type of simple physical method. Next, what do we see here? We see a kitchen, right? And this lady is trying to separate something. We see a bowl in her hand, okay? And there is something kept in the bowl. Let's see what she is up to. Can you see closely? It is a bowl. It is a sieving bowl, right? It's a sieving plate. There's flour on top. What do you think she is doing? This is called sieving. So, have you all noticed, before making rotis, our parents, especially our mom, she first uses the sieving plate to separate all the impurities from the wheat flour, right? Before making chapatis. So we use the sieving plate and then we just do this thing, shake it. So what happens? All the flour goes down and the impurities stay on the top. It stays on the sieving plate. So this is another simple physical method to separate the components. So all the impurities stay on the top of the sieving plate and all the flour that we need goes to the bottom. So this is called a sieving method. This is another type of simple physical method. Okay. Next, we see another kitchen scenario here. So the lady is trying to make something. Can you see it's orange in color? What do you think it is? Yes, she's trying to make tea. So, have you all noticed after boiling tea, what do we do? The first thing we do before drinking the tea. So, we separate the tea leaves from the tea, right? The milk tea, we separate the tea leaves before we drink the tea. So this is also a type of separation, children. So what is this type of separation called? This is called filtration. So when you separate the tea leaves from the tea, this is called as filtration method. So we use this before drinking the tea, right? So this is another type of simple physical method. What is this? This is a heterogeneous mixture. So you have milk, the liquid, and then we have tea leaves, which is solid. So it is a heterogeneous mixture. And before we drink, we separate it through filtration. So these three are simple physical methods to separate heterogeneous mixture. What are the methods? First one is hand picking method. Second one, sieving method, where sieving plate is used. In the hand picking method, hands are used to separate the impurities, and in the filtration method, the filtrate or the funnel is used to separate the impurities from the milk, or in milk in this case. So these are the simple physical methods. Do you think we can use the same simple physical methods to separate milk here? Can we use hand picking method to separate milk, or can we use the sieving plate to separate milk? Do you think that is possible? Or do you think we can use petroleum in the same way? Can we use the same methods to separate petroleum constituents? Or maybe ink constituents. Do you think ink can be separated using hands? Do you think that's possible? Or do you think water and oil? Have you seen water and oil forming two different layers when put together? Can you dip your hand inside and take the oil out, or can you dip your hand inside and take the water out? Do you think that is possible? Do you think milk, petroleum, ink, or oil and water mixture can be separated using simple physical methods? No, right? We need some other methods to separate this. You cannot use hand picking or cannot use filtrate funnel method to separate these. So sometimes special techniques have to be used for the separation of components of a mixture. In case of milk, in case of petroleum, we need some special types of filtration or the separation methods. Let's see what are those. So first let's see ink. We all use ink, right? We all use those fountain pens where you put ink inside, or we have pens where the ink is already filled inside the tubes. How are they? There's no only one component, right? There are several components in the ink. There's dye, there's other components. How do you separate it? So method to obtain colored component, that is the dye of the ink, from blue or black ink. So ink has several different components in it. So how to obtain the dye component from it? So you can see an apparatus set up here. We have the Bunsen burner, we have a beaker, there's water, and also there's a watch glass on top. We can also see ink in the watch glass. What do you think they're trying to do, children? Let's see, let's find out. So like I said, the water here is boiling. Okay, you can see the bubbles coming up. So that is boiling. Then there is a beaker there. Then there is a watch glass and ink. So since the water is boiling, the ink is being heated up. And then you can see vapors going up, right? So there's water heating up, the vapors are going up. So what's happening here? Water has evaporated from the ink. So because of the water boiling in the bottom, the water in the ink component is evaporated. So what's happening? The solid dye which is in the watch glass is left behind in the watch glass. So there is water which is being evaporated from the ink component, and only the dye, the solid dye which cannot be evaporated, is left behind in the watch glass. Okay. So we can separate the volatile component. So what is volatile component here? Volatile component is something that can be evaporated. Do you know any other volatile components? Let's say petrol. If you keep petrol open in the atmosphere, it very quickly it dries out, right? In the same way, we have our nail polish removers. If we keep it outside, very quickly it's all gone. It's dusted. It is all evaporated. So this is called volatile component, which evaporates very quickly. So we can separate this volatile component, which is a solvent. In the ink case, the water is the solvent. The water is a evaporating substance. It is a volatile component here. So that is a solvent. This can be separated from its non-volatile solute. Non-volatile, which cannot be evaporated. So that is called as non-volatile solute. The solute here is the solid dye. So this non-volatile solute, that is the solid dye, is separated from the volatile component, that is the solvent, that is water, by this method. So water evaporates and the solid dye, which cannot be evaporated, is left behind in the watch glass. So this is how you separate the ink components. And what is this method called? It is called evaporation. So water is evaporated. The solid dye cannot be evaporated. It cannot be evaporated. So water can be evaporated. So what is this method called? It is called evaporation method. So this is a special type of the separation method used here and to separate the ink components. Let's go for another question, shall we? A mixture of water and silver chloride can be separated by what? Can it be separated by centrifugation, B. Sedimentation, C. Filtration, D. Sublimation? So, you get 30 seconds of time like always. Guess the right answer. A mixture of water and silver chloride can be separated by what method? Filtration or sedimentation or centrifugation or sublimation? You have 15 seconds of time. You can guess. I think it's very easy question, right? We just spoke about this. We have 5 seconds. Now 3, 2 and 1. So the answer is filtration method. A mixture of water and silver chloride can be separated by filtration method. Okay, I hope you all have guessed it. In case not, that's okay. Let's move on. So now let's see method to separate cream from milk. So how do you separate cream from milk? Have you all seen milk at home? Have you all seen buttermilk at home? We use something, no? We use something, that stick kind of thing, to separate some cream from the buttermilk or cream from milk. How do you separate it? Can we use the same filtration? Can we evaporate? Okay, take an instant where you have kept milk boiling, okay, and then you forgot about the milk boiling. So after some time, after half an hour, you come and see all the milk is gone, right? So you cannot use evaporation method to obtain milk. So what other methods can we use? Let's see. So a method to separate cream from milk or to obtain cream from milk, this can be done by using a milk churner, which is used in the kitchen of our home. So have you all seen from the buttermilk, we use that stick kind of thing, we spin it around and we get some cream, right? So that is called as churner. Let's see how it looks like. So this is the churner. Now I think you got it, right? So this is not only used for buttermilk, it can also be used to get cream from milk. So you use this churner, you spin it around, and that's how you get the cream. But do you think we can use this in the laboratories? No, right? Why? Because of the hygiene requirements. So in the laboratories, centrifuging machine is used to separate cream from milk. You cannot use the churner in the laboratories because of the hygiene standards you have to practice in the laboratories. So what do we use? We use centrifuging machines. There are certain machines which are used to obtain cream from milk. So this is the centrifuging machine, okay? So you see those blue spaces in between. So these blue spaces is where you keep the milk components or the milk, and then you use some force to separate the components of milk to obtain cream from milk. Let's see what's happening here. So you have some test tube, right? There's a test tube holder, and now what's happening? Milk is being transported or transferred into this test tube, which is called a centrifugal tube. From the test tube, you put some milk into the centrifugal tube, and now what do? We keep this tube in the centrifugal machine. So this is how the centrifugal machine looks like. And children, remember that the opposite sides of the centrifugal machine should always be equal. So in case you put milk in one side, the other side should also contain the same amount of milk or water or any quantity, but the quantity should be same, okay, on the opposite sides. So now you took the milk in the centrifugal tube and then you've put it in the centrifugal machine. So what do we do next? We spin it, okay, we spin it. What is happening here? Centrifugal force is being applied. So as much as you spin, the force is being applied to the milk. So what happens after you spin? After some time, so the milk components are separated. So you can see two different layers over in the centrifugal tube, right? So there's one layer, the white layer on top, then there's transparent layer in the bottom. So because of the centrifugal force, because of the centrifugal machine, two different components or the two different layers have been formed. What are these two layers? So the top layer is called as cream. The top layer is the cream that we need, and the bottom layer is called as skimmed milk. So this is the other components of milk, just being separated. How? From the centrifugal machine, and because of the centrifugal force that has been applied. Two layers, cream layer, and the second layer is called as skimmed milk. Okay. So this method is called as centrifugation method. But why do you think cream is in the top, and why not the skimmed milk is in the top? Why is only it's the cream? Let's see why. In the centrifugation method, the denser particles are forced to come to the bottom, and the lighter particles stay on the top when it spin rapidly. So we saw it spin rapidly, right? So what happens? The denser particles. Here, what is the denser particle? The skimmed milk is the denser particle. Now that goes and settles in the bottom, and the cream is the lighter particle. It is not as dense as skimmed milk. So what happens? That gets settled on top. So this is the method used in the centrifugation. Okay. Like I said, cream is lighter than milk. Hence, it floats on top of the milk, and the skimmed milk is heavier than cream. So it gets separated and it gets settled in the bottom of the centrifugal tube. So this is how we get cream from milk in the laboratories. Okay. At home, what do we use? We use churners. So that is how we get cream from milk at home. But in the laboratories, we use this method. What method? It is called centrifugation method. Okay. Now, centrifugation. Where do we use the centrifugation? We understood we use it at home. We understood we use it in the laboratories. But what are the other places where you can use the centrifugation method? Let's see the applications of centrifugation. This method, where do we use this? Here, it is used in diagnostic laboratories for blood and urine tests. So, whenever you have fever or whenever you feel uneasy, you go to the doctor, and what is the first thing they do? They ask for blood samples from you, right? So what do they do with these blood samples? They use the centrifugation method to separate the blood components. So in the diagnostic laboratories, in the blood and urine tests, centrifugation method is applied. Like I said, you give the blood samples from your veins, it is collected in a test tube, and then what happens? It is then taken and it is put into the centrifugal tube and then into the centrifugal machine. So here it is being spun. So after a long time, your blood components are separated. So you have blood particles, then you have plasma particles on the top. Since blood is heavier, it settles in the bottom, and then since the plasma particle substances are lighter, it goes on the top. So you can see this yellow thing, that is the plasma. The red thing, this is the blood. So it gets separated. So this is the so here also centrifugation method is used to separate blood components. Okay, this is used in the diagnostic laboratories. Next, it is used in dairies and home to separate butter from cream. Like we said before, in the dairies they use some machines. At home we use those churners. So again, centrifugation method is used to separate butter from cream. Earlier it was cream from milk. Now here we are separating butter from cream. Okay. So this is the machine which is used in the dairies to separate what? To separate butter from cream. Where it is used? It is used in the dairies. So you can see the machine. You put milk here, and then through some centrifugal force, all the butter is separated from cream. Once you get cream, and then you get butter from it. Okay. So it is also used in washing machines to squeeze out water from wet clothes. So when you put clothes in the washing machine, how do they come out? Do you see water dripping through your clothes? No, right? It's usually dry. The water is removed. Your clothes are usually dry. So what happens in the washing machine? So centrifugation is again applied in the washing machine to squeeze out the water. How? You see your washing machine spinning, right? Once you turn it on, it starts spinning. What's happening? The water is being removed in the end. So you get the clothes usually dried, right? So that is a washing machine. You put all your clothes in, you turn it on, then it starts spinning. All the dirt is removed, and in the end, all the water is also squeezed out from it. How? Due to centrifugal force. Or what's the method? It is called centrifugation method. So the water is removed out, and you get only dry clothes in the end, right? So this is how you use it in the washing machines. So what are the applications? We saw it is used in the diagnostic laboratories to remove the blood samples. It is also used in the other laboratories or the other industries to get butter from cream. It is also used in the washing machines to what? To squeeze out the water from wet clothes. Okay. Now let's have another question time, shall we? So, how can we separate cream from milk? We just spoke about this, didn't we? A. Centrifugation method, B. Chromatography method, C. Sublimation method, and D. Distillation. You have 30 seconds of time and the time starts now. Guess children, this is very easy, right? We just spoke about this. How can we separate cream from milk? We spoke so much about it, right? Guess. What do you think? Centrifugation or chromatography or sublimation or distillation? What's the answer? 3 seconds, 2, 1. So, what is the answer? Yes, centrifugation is the answer. How do we separate cream from milk? From the centrifugation method. We just learnt about this, right? Yes, very good. I hope you all have answered this. You have, right? So, we have another scenario here. What do we see? We see a lady. She has a cooking oil in her hand. She's trying to make something, I guess, maybe pakoda or something. And she also has a beaker there. But do you notice a little bit of water in the beaker? Then what she's doing? She's trying to pour this coconut oil into this, cooking oil into this beaker. There's a little bit of water also here. Let's see what happens. So she poured all this cooking oil into the beaker. What happened here? The oil layer formed a separate layer and the water is remained in the bottom. So what happened? What is she saying? Oh, what did I do? A packet full of oil is wasted. Why is it wasted? Because we cannot separate oil and water by using simple methods, right? We cannot separate it at home. We cannot just put our hands inside and remove the water component, or you cannot just pour the oil separate and water separate. It cannot be separated that easily. So what is she saying? She's saying that the cooking oil is wasted here. The whole packet of cooking oil is wasted. So do you think there are any methods to separate water and oil? Because they always form two layers, no? They do not get mixed up. No matter how many times you shake it or you swirl it, you do anything, it always form two separate layers or two different layers. So liquids which do not mix with each other are called immiscible liquids, like water and oil. No matter how many times you swirl it or shake it or whatever, they always form two separate layers. So liquids which do not mix with each other, like water and oil, these are called as immiscible liquids. Okay. So how do we separate these two immiscible liquids, two liquids which cannot be mixed together? How do we separate these two? There are some methods. Okay. So let's have an experiment. Let's see what they're doing. There's a table, there's a larger beaker, and then there's a smaller beaker with water, right? So we pour water into the larger beaker first, and then we take oil. We again pour this oil into the larger beaker. So what's happening here? There are two separate layers formed on the table. So we have oil layer which is on the top and the water layer which is on the bottom. Why do you think oil is on top? Yes, because oil is lighter than water. So water is denser than oil. That is why it gets settled in the bottom. And oil, since it is lighter, it goes and settles on the top. Okay, so that's how two layers are formed. So oil, like I said, oil floats on top of water. Why? Can you repeat the same thing? Why? See, you can see two separate layers, no? We just spoke about this. Let's recall again. The density of water is greater than the density of oil. So oil is lighter than water. Hence, the layer of water is below the layer of oil. Why? Because it is the water is heavier than the oil. That is why water gets settled on the bottom and oil gets settled on the top. That is why we see two layers. What are these? These are immiscible liquids. They cannot be mixed together, right? So how do we separate it? So there's an instrument. So the instrument used to separate two immiscible liquids like water and oil. It is called separating funnel. So this is the separating funnel. Here we put the mixture of water and oil and then we separate it. How do we separate? Let's see. So you have the mixture. You have water and oil mixture. You have separating funnel here. This is the mixture. And what are they doing? They're trying to pour this mixture into this separating funnel, right? See, now they poured it. Again, water and oil form two different layers. So water is on the bottom and oil is on the top. Once you pour, again they form two different layers. What do you think can be done, students? Think over it. So you have a separating funnel. Look at the shape of it, and look at the bottom. We have a tap here. What can be done? Think. Let's see. So first you need to mix it. Why? To separate it evenly, to separate it properly. Once you shake it vigorously, but again, like I said, it forms two different layers, oil layer and water layer. So now what are they doing? They open the tap. So once you open the tap, what happens? All the water components or the water comes down into the beaker, right? As soon as all the water has been transferred into the beaker, they turn the tap off. So what happens here? Simple, right? So the water has been separated from the oil. Once you open the tap, all the water comes down. You close the tap, all the water is on the bottom and all the oil is in the separating funnel. So this is how you separate two immiscible liquids. You shake it, you put it in the separating funnel, you again shake it properly to distribute it, and then again it forms two different layers, and then you open the tap. All the heavier component goes down first, because water is heavy. It first went down, and then as soon as all the water is in the beaker, you close it. What happens? The lighter component, that is the oil here, the oil remains in the separating funnel, and then the water, which is heavier, gets transferred into the beaker. So this is how you separate two immiscible liquids. Okay, so this is called as separating funnel method. Okay, where is it used? It is used in the immiscible liquids. So immiscible liquids can be separated by using separating funnel. So we saw that separating funnel, and this method is called as separating funnel method. Where it is used again? It is used in the immiscible liquids. Okay, to separate these immiscible liquids. So separating funnel method. What are the applications of separating funnel method? Where do you think can we use these? So it is used during the extraction of iron from its ore. Have you seen iron? It is not how it is found. Iron ore is the initial stage of the iron. It has lot of impurities, okay, the iron ore, and then these impurities are separated out, they are thrown out, and then you get the pure iron. So what method is used? The separating funnel method is used to extract the iron from its iron ore. Okay, so this the machine which is used to separate iron from the ore is called as blast furnace. So you can see in the bottom there is something called slag. So this is the impurity. So slag is lighter than the iron. So what happens? It gets settled on the top. There are a lot of other temperatures. This temperature favors the separation of the slag and the iron ore. So the slag gets settled on the top, and the iron, the molten means a little bit of liquid. So that iron is on the bottom. Okay, so because it is heavier, it gets settled on the bottom. So you can see two out, and you can see slag out and molten iron out. So what are these pipes? So the slag is used to remove first. So it is removed from the slag outside, and then the iron is removed from the molten iron outside. Okay, so what's happening here? The lighter slag, like I said, the slag is lighter component. It is removed from the top. So this is the top layer. So it is removed from the top, leaving the molten iron in the bottom of the furnace. So the molten iron remains, and the slag, which is the impurity, is removed out through what method? To separating funnel method. So the iron is remained, or the iron is later removed through this side. Okay, the impurity, which is slag, is removed through this side. So what happens? The lighter slag is removed from the top, leaving the molten iron at the bottom in the furnace. Now we have another experiment here. Let's see what's happening. We can see three watch glasses, right? One has iodine, one has salt, and then there is an empty watch glass. What do you think they're trying to do? Let's find out. So, one scoop of iodine is put into the watch glass, right? One whole spoon of iodine is put into the watch glass, and then one whole spoon of salt is put into the same watch glass. What's happening? There's iodine and salt in the watch glass. So what are they doing? They're trying to mix iodine and salt. So now we have a mixture of iodine and salt. Do you think we can pick it up? No, because they're very small components, right? We cannot use simple hand picking method or sieving method to remove this, because it's a mixture. They're very small components. You cannot randomly separate them out. So we have a mixture of iodine and salt, right? So how do we think we separate it? How do you think? We cannot use evaporation method again. Why? Because there's salt. Both iodine and salt cannot be evaporated that quickly. Or you cannot just use separating funnel. Why? Because it's not liquid. So what do you think? Think over it. It's a salt plus iodine mixture, right? So how do we separate it? Let's see. But before that, let's have a question time again. So when two liquids do not mix, they form two separate layers and are known as what? We just spoke about this, no? Two liquids which do not mix, what are they called? Either are they called miscible liquids, are they called immiscible liquids, or saturated liquids, or supersaturated liquids? You get 30 seconds of time, so think over it. What are the two liquids which do not mix together are called? Either immiscible liquids, or miscible liquids, or supersaturated liquids, or saturated liquids. Think over it. You have 15 seconds of time remaining, okay? You have 5 seconds. 4, 3, 2, 1, and done. So what do you think? Yes, the answer is immiscible liquids. We spoke a lot about this. So what happens? When two liquids do not mix, they form two separate layers. What are they known? It's called as immiscible liquids. Okay? So, how to separate this salt and iodine mixture? We just spoke about this, no? How do you think we can separate it? So, some substances, when heated, changes directly from solid to gas without changing into liquid state. So some gases, when cooled down, gets converted to solid. So we have something new here. What's happening? So when you heat some solid, it usually what happens when you have ice, you heat the ice, what happens? It melts down, right? So ice becomes liquid when you heat. But there are some substances which directly converts from solid to gas without going through liquid state. Okay. Also, there are some gases which become directly to solid, which do not condense to form liquid. So there are few substances. What are these substances called? Again, like I said, solid when heated, it directly becomes gas without becoming liquid. Okay. And when it is cooled down, it becomes solid without become liquid. So the liquid state is not present in these substances. They do not go through liquid states, either from solid to gas or from gas to solid. So what are these substances called? These are called as sublimable substances. Okay, so what are the sublimable substances? Some substances when heated change directly from solid to gas without changing into liquid state, or some substances from some gases when cooled down, when they are put under low temperatures, they get converted to solid without going through liquid state. So what is this called? These are called as sublimable substances. Okay, I hope you've understood till now. So let's see how iodine and salt is separated in the next class. Okay, I hope you understood all these topics. I hope you have a good day. Thank you.